The adaptive immune system has a mechanism where it stores these lymphocytes for future attacks. We call these memory cells. These memory cells are circulating in the lymphatic system. They're found in lymph nodes and in circulating lymph, kind of ready for the next event from that specific antigen. Remember that the adaptive immune system, T cells, B cells, are going to be work because of a specific antigen that they're attacking. They're not non-specific. They're not attacking whatever pathogen is entering the body. They're quite specific in the in the antigen that it's recognizing, ultimately the pathogen, and it's quite efficient at destroying these microbes. So we actually have something called a primary immune response and a secondary immune response. Let's go ahead and talk about that. And I'm actually using antibodies as a concept to talk about this. Allergies, that's going to come up on the next slide, is another is a really good event to also describe the primary and secondary immune response. It doesn't always have to be a pathogen that causes this. Okay, so we have an antigen, not necessarily a pathogen. We have an antigen that we're exposed to. So it's going to be a foreign molecule that our bodies are perceiving as a threat to our systems. And so we're exposed for the very first time to this antigen on day 0. About a week later, day 7, we start making antibodies. There's a delayed response. There's always going to be a little bit of time, a little bit of lag time for those immune cells to start recognizing this antigen, for those antigen presenting cells to start synthesizing that protein that they're going to then present to the T helper cells, those CD4 positive cells, who are then going to also promote the T cells or the B cells. That's all a lag time. That takes some time in order for that to happen, in addition to the immune cells actually getting to the spot that they need to get to for the attack. So about a week later, we start seeing antibodies being secreted by B cells. Okay, that sounds like that's the method that this immune system wants to use, the B cell method, in order to defend itself. So this is called a primary immune response, and I can actually see that antibody concentration increasing. And there comes a point where it's going to reach a max concentration of forming antibodies to defend itself. And then it starts decreasing from then on. That's called the primary immune response. Let's say that we are exposed a second time to that same antigen. Your immune system is ready to attack. In fact, your immune system is so ready to attack this foreign substance that it might even attack these guys without you all even knowing that you're infected. So here we have a second exposure, and remember it took a week, about 7 days to even start making the antibodies. Well, here's 28 days. Already by day, I'm going to call this day 30. So over here's day 35. So I'm going to say day 30, just about 2 days later, boom, look at that antibodies being made. Those B cells, those memory B cells are ready to start synthesizing those antibodies. And it actually happens pretty quick and pretty dramatically. Check that out. Right here was the peak antibody concentration that the primary immune response gave. Well, the secondary immune response is going to go even further, even extra than that primary response, and in a short amount of time. And then we start seeing a decrease from there. So the second time we're exposed to an antigen, and any subsequent exposure to that exact same antigen, the same specific antigen, our bodies are ready to attack. It has to do with those memory cells being stored, being ready to synthesize. It really ultimately has to do with these immune cells remembering how to attack these substances. I'm going to go back to show you. So an antibody, because I'm using that as an example here, has these antigen binding sites, and these are variable according to the antibody. These antigen binding sites have to do with the specific antigen. Here I see an antigen coming in, looks like a purple balloon, to those sites. They're going to be specific, and they're very tiny little sites on the antibody, but now those memory cells are remembering how to form this area on themselves. Okay, I need to go ahead and form myself in such a way to recognize that antigen to cause an immune response. The secondary exposure is so efficient at this process. The primary, it will get there. It takes time in order for those cells to do that. In this image, I have the primary and secondary immune responses being shown when an allergen is coming up into our bodies. And an allergen is not necessarily a pathogen to where it's going to cause infection, but an allergen is a substance that we are identifying as anything found in the environment that triggers an immune response, and it's not intrinsically harmful. So we're talking about peanuts, fish, eggs, celery for some people, sulfites, sesame seeds, milk can cause allergies. Any number of substances can cause allergies, and it has to do with that they're not usually harmful for humans. Some humans do find them harmful, so they cause an immune response. If you suffer from allergies, you might be aware that the second time you're exposed to something or subsequent times that you're exposed to a substance, it's more severe. Your reaction is a little bit crazier compared to the initial response that you had, maybe before you didn't even have a response to that allergen. Second time, subsequent times, over the top reaction, your immune system. Well, that has to do with these primary and secondary immune responses. Here I can see an allergen coming in by these orange structures, and it's being recognized on that antigen area, recognizing area of the antibody, of this B cell. Here's a B cell. Okay, that's the initial exposure. That guy's going to release the antibodies, that B cell. These are actually IgE antibodies because we are talking about allergens. And ultimately, what IgE antibodies do is they promote mast cells or basophils, basically histamine-containing cells, and they're going to promote the release of that histamine. But they don't do it so efficiently in that primary immune response. So what we have are a lot of these kind of memory B cells that have these antibodies that adhere to these mast cells. And I can see the IgE antibodies here, and they're going to stay on that mast cell, ready to defend itself against that allergen that's going to come in. Your immune system is thinking, this guy's harmful, I'm going to get you the next time that you come in, so that the next time, the secondary immune response, these guys are ready to attack. And we see that here comes an allergen ready, but those mast cells coated with the IgE antibodies are ready to release their histamine, and that's going to promote an allergic response. It can be quite severe to the point where the patient undergoes anaphylactic shock, which will be extremely harmful for the patient.